This is the video for the produce truck dynamic programming routine. Here we have two parts of the routine. We have over here on the left selling apples. Over here on the right we have buying potatoes. There are two other routines that we're not showing here, and that would be buying apples, and over here selling potatoes. We're just going to go through one sell and one buy routine. Again, there really are four routines, but actually at any time you're at a particular city, you're either buying apples or selling apples, buying potatoes or selling potatoes. So actually every time you visit a city, you are only doing two of the routines. Well, we'll start over here where we're selling apples. First, it checks to see that we are selling because of what the price is. If it's not selling, we're going to go to BK, which is another routine. First, it sets P to 0. P is going to be used for the previous balances. Right down here, we'll see it being used for the previous balance. And we'll see there's two loops here for A0 and for B0. And down here, where it's next B and next A, we notice right before that it added 1 to P. These two loops go around the max bin number of times, which is 15. Well, you say the maximum number of bins is 14. But actually there could be 0 bins. So it's 0 to 14, which is 15 possibilities. And here we have 15 around 15. There's 225 values for P. Well, let's go to the loops. First for A0, and down here we see next A to max bins. Then it sets the have potatoes to A. This A is going to tell it how many bins of potatoes that are on the truck. Then we're going to go to 4B from 0 down to next B, the maximum, and that's for have apples. And here it says set have apples to B. That's how many bins of apples are on the truck. Then we can say branch if less than the have apples is less than 1 to BG. We don't have any apples, we can't sell apples, so it goes right down here to BG, and we'll go to the next previous index or offset. It increases P. Well, if we do have some apples, we also check to see if the balance of apples is equal to W. W is the non-existent value. It's a very high negative value, which is used to say we don't have a previous balance. So the same thing happens of not having apples. Also, the previous balance of apples doesn't exist. So we go to BG, and we go down here again and increase P to the next previous. Well, if we do have a previous and we do have apples to sell, it says set the sell price to the apple price for this city. L is the offset for this city for both price and next for the limit, how many can be purchased. So the sell maximum is set to that limit. But maybe that's more apples than we have. So then it says, well, branch if the sell maximum is less than equal to have apples, well then it's okay. But if not, we have to set the sell maximum to how many apples we have. Because right here we're going to go around a loop for how many apples do we have, the sell maximum. Well, we first set our sell total to the sell price. We're going to go around for one apple bin we're going to sell. So we set the sell total to 1. But as it goes around down here, it's going to add the sell price each time we go around and say, now we're getting more money. Here it says, set Q equal to P. It's going to start at the point this previous point, and then it's going to subtract 1 from that every time. We're going to go down from there. We're selling apples. We're going to have less apples. So the first thing it actually does is it subtracts 1 from Q because it wants to sell only 1 apple. Then it sets the test total to the sell total. That's what we had here. Then it adds to it the previous balance. Remember, P stands for what value do we have with this many apples before. So previous apples, or P, adds that to it. Alright, then it checks to see if this is a better total than is already at the new balance at offset Q. See, we're going around here changing Q each time. If it's no better than the solution we had before, it goes down here to BF, and then adds this and then goes around the loop again. But if it is better, then we set the new balance Q to this test total. And so it has a trail back to the beginning. We must remember where it found it. And we say, well, if you're at this index for this particular city, you go back to P. That is your offset when you go to the previous city. So this is how it will know how to go backwards through the cities. Remember, this is dynamic programming. We're solving these little problems each time. In this case, we're selling apples, and we're figuring out how many apples we can sell, and if we sell so many, we're remembering what the best thing is for it, and we remember our trail back. Well, once we go through all of this, we do the loop for B and over A. We're going to move our return index, this information that we gathered here, and put it in all returns at offset R. Well, this is the rth time we figured it out, the best solution, so we're going to save that so we can go back. Remember, we need that information to go backwards to find out the best solution. Then we add R jump to R. That's so we then go to another place where we're going to store another return index set into all returns. Alright, this is selling apples. Over here, our example is buying potatoes. The loops seem very similar. We have P set to 0. Down here we add 1 to it. That's for the previous solution we're going to look at. P's for previous. We're going to go around for all the apples and all the potatoes. Well, first it says A here. Set have potatoes to A. And then for B, set have apples to B. Have potatoes to A, have apples to B. Then it says branch if less than or equal the previous balance P is less than or equal to W. That W again means invalid. So it goes right to FG and says, well, I don't have anything previous. That's EG, isn't it? EG, I don't have anything previous. So I go down here and go through the loops again. Otherwise, we come up here, if that's it, we set the potato buy maximum to the maximum number of bins, which is 14. Then we subtract for how many apples we have. We have some bins of apples on the truck, so we can't really buy 14 more, but 14 less the number of apple bins we have on the truck. We also subtract the number of potato bins we already have on the truck. Then we say if that is maximum is less than 1, well, we can't buy any potatoes, can we? So it's going to go to EG. Our truck is full already. Well, if our truck isn't full, it says here we're going to set the buy price to the potato price of city L, the buy maximum to the potato limit at city L. I guess I should remind you again, we're going to do this for every city. We're going through every city. Boom. And the offset for the city is L. Well, we have to check the buy maximum against the potato buy maximum. And whichever is lower is what we set the buy maximum to, because down here we're going to go around the loop for the buy maximum. Similar to on the other side here, we're going to set the buy total to the buy price. And then down here, every time we go around to buy another bin, we add the buy price to the buy total because the cost increased. Then we set Q to P, just like before. We set it to the point in the array that we're at, because that's determined. That changes every time we go around. That's our point where we're starting. And then we set Q to that value. But in this case, we're going to be adding the row count to it, because the potatoes are changing in row. They're actually a column of them. So we change by the row count each time. This is an array that is 15 by 15. The upper left corner of the array is 0, 0, and the bottom right corner is 14, 14 for the number of bins. Potatoes is different than apples. Apples over here just changed it by 1 each time. This is potatoes. It changes by the rows. Okay, so Q will change by the row count each time. Then we have to see what point we're at dollar-wise. We set the test total to the buy total. That's how much it costs to buy it. And then we add to that the previous balance of P. Remember, this whole thing here has to do with the previous. We're checking it for every previous, from 0 up here all the way down here. It'll eventually get to 225. Right, we're checking it for every previous. If it's greater than or equal to, well, the new balance of Q that we're figuring out here is big in test total, we ain't going to do it. Otherwise, we are, and we're going to set the new balance Q to this test total. We're going to set the return index of Q to P. So it'll always know how to get back to the previous one. All right, we know about this adding the buy price to the buy total. Here's where it adds 1 to P each time, and here it goes around 16 over 16 from 0 to 225. And down here we see it's going to move that information into all returns of R and add the jump to R. So it's going to go to another return index list. All right, this is the basic of the produce truck dynamic programming routine.